The deployment of the load balancer is complete. Let's click on Go to Resource button and understand the various options we have to successfully configure the load balancer. In this lesson, we'll understand about the backend pools, the load balancer rules, the session persistence, health probes, the TCP custom probes, and various other options we have when configuring the load balancer. The first thing that you always got to check is the front end configuration. So I'll click on the front end IP configuration under settings, and you will notice that the front end configuration is already there. Now this is nothing but assigning a public IP address to the load balancer. So under overview, the public IP address must be assigned to the load balancer. It should not be a name, it should be an IP address. If you ever see a name, that means it's a problem. It's some time to troubleshoot. If you see a name like this, it means it is either not configured properly or it's time to troubleshoot. That's what it means. Okay. Now, because we have not configured the load balancer completely with the backend pool, with the health probes and load balancing rules, you do not see an IP address yet. So let's go ahead and configure the backend pool now. Now, if I click on backend pool, you will have the various options to add a backend pool for your load balancer. But what is a backend pool? To distribute the traffic from the load balancer to the ones that are assigned to the load balancing, you need something called as a backend pool. A backend pool contains the IP address of the virtual network cards that are connected to the load balancer. Well, it could be any one of these options that are there, like it can be a virtual machine or it could be a virtual machine scale set. Now, because we have a basic load balancer configured here, we are able to see just these two options. But if you had a standard load balancer configured, you can have an availability set configured as well here. Also keep in mind that in a standard SKU, you can have up to 1,000 instances in the backend pool. In the basic SKU, you can have 100 instances. Let's go ahead and configure the backend pool. I'll give the backend pool name as type backend pool or something here. And then the virtual network is that it is automatically picking my virtual network because my load balancer is in East US. And in East US, this is the only virtual network I have. So I'll click on that and then assign it to either a virtual machine or a virtual machine scale set. I'll click on virtual machine at this time, and then it will automatically show up the virtual machines that I have in that region in that virtual network. So that's web server 1, and its private IP address is automatically populated. I will also select the second web server and its private IP address. So when the traffic hits my load balancer called as web load balancer, it will then come and assign it to either web server 1 or web server 2 depending on how busy they are. I'll click on add to add and validate the backend pool. It will take a minute or so to validate and add the backend pool. So the next thing that we have to do that once it is ready is go ahead and configure a health probe. So while it is doing that and busy configuring the backend pool, let's understand what a health probe is. A health probe allows the load balancer to monitor the status of your application on the web server. The health probe dynamically removes any unhealthy web servers from the backend, so they do not participate in the load balancing act. So that means that when a probe from the load balancer to the web server fails, then the load balancer stops sending any new connections or any new traffic to the unhealthy instances. So there may be reasons why the server may go unhealthy. The reasons could be probably you are patching the server or the web developer is doing something with the web server that's made its connections bad. Maybe the services have stopped because you just restarted it. Maybe there's an antivirus blocking incoming connections. Well, there could be lots of reasons why the web server 1 could be unhealthy. But if that scenario ever happens, then we say that the load balancer will not talk to the web server. Well, there are several ways in which you can configure the health probe. You can configure it in HTTP custom probe or even TCP custom probe. We'll understand that when we are configuring the health probe of the load balancer. Okay, the backend pool is successfully configured now. We got two web servers here. Now I'll click on the health probes to configure the health probes. Click on the add button and then you will see that you got multiple options. You can configure it based on TCP or HTTP? Well, these are the two probes that I was just referring to. So when you select a TCP based custom probe, it means that this probe will rely on establishing a successful TCP session on the defined port that you're defining here. So if the specified listener on the VM exists, so if port number 80 exists and it is properly listening, then the connections are accepted. If it is not listening on port number 80, then the probe will fail and the connections are not accepted, and that virtual machine will then be marked as unhealthy. We can specify the interval the probe should happen, which is the frequency of the interval. So that means that the load balancer will probe the virtual machine or the web application every 5 seconds, and it will consider it as unhealthy if it fails for 2 consecutive times. Let's also talk about the HTTP method of probing. The load balancer regularly probes your endpoint, which is every 15 seconds by default. So the instance is healthy if it responds with an HTTP 200 within that time period. Any status other than HTTP 200 causes the probe to fail. So HTTP success code is 200. And if you get anything apart from 200, like 303 or 404, it means that the probe will fail and that web server will then be considered as unhealthy. You can define the port on which the probe should happen, the path on which the URI request should happen. So the request will happen to check the health status on that particular backend path. And you can also define the amount of time between the probe attempts and the number of failures that must occur for the instance to be considered as unhealthy. If the number of failure attempts are more than 2, then it is considered as unhealthy. Of course, you can go ahead and change these numbers. These are the default values and also mostly used in production. But if your application or the business has different numbers to specify, you can add them here. I'll click on OK, but before that, I'll give it a name, call it as health probe, and then just say OK here. Now, by using an HTTP health probe, I'm saying that if the web server is not available on the port number 80, then consider it as unhealthy. Again, adding the health probe is not instantaneous. It takes a while to get that updated. And while that is getting updated, let's go ahead and talk about load balancing rules. A load balancing rule is used to define how traffic is distributed to the backend pool. There's a rule that maps a given front-end IP and a port combination to the set of backend IP addresses and a port combination. Now, to create this load balancing rule, we must have the front-end IP, backend pool, and health probes already configured. So now that we have a message here which says that the probe is created, I will go ahead and click on load balancing rules and then click on add. I'll give the rule name as LB rule here. Okay, and make sure that you don't give any spaces like me. And then the version is IPv4. I'm not using any IPv6s here. The front-end IP address is something that we already configured. It's available in the drop-down menu. I'm going to have all the traffic go on port number 80 TCP. The backend port on which my web applications are listening on is also port number 80. My backend pool is configured here and available in the drop-down menu as well. The health probe is something that we just defined, and then there's something called as session persistence. So what is session persistence? By default, Azure Load Balancer distributes the network traffic equally among multiple virtual machines. That is what it is supposed to do. The load balancer uses an algorithm called as 5-tuple. The 5 tuples here stands for source IP, source port, destination IP, destination port, and the protocol type. These are the 5 tuples. So this algorithm is called as the 5-tuple hash. The load balancer uses the 5-tuple hash to map the traffic to available servers. It provides stickiness only within a transport session. So do you want that stickiness to happen? Do you want the traffic to be sent to that particular IP only? So if the connection or the traffic is originating from a particular IP, let's call it as connection 1, and then if it lands up in virtual machine 1, do you want that connection to persist always? So the session persistence specifies how traffic from a client should be handled. The default behavior is none, and that means that successive requests from the client may be handled by any virtual machine. And you can change this behavior by selecting client IP or client IP and protocol. So if I select client IP here, that means that based on my client IP addresses, the traffic will be sent to a particular virtual machine only and not to all of them. So the client IP means that any successive requests from the same client IP address will be handled by the same virtual machine. But if I select client IP and protocol, it means that any successive requests from the same client IP address and protocol combination will be handled by the same virtual machine. Keeping the session persistence information is very important in certain applications. For example, using e-commerce applications that use a shopping cart. Okay? Now, these values are really important to configure the load balancing rule. I'll just click on OK here and wait for this to finish. Okay, now that the load balancing rule is added, it has stopped updating. We can see the rule here. I will go ahead and quickly click on the overview section here, and then I see the public IP address. And that's what I'm saying, that we need to configure all these four parameters to have the public IP address in place. What we can simply do is copy this part of the public IP address, or even maybe the whole part of it, and then paste it in the address bar and remove this particular section and then hit enter. There you go. So this traffic from the public IP address of the load balancer took me to web server 1. Well, you may hit refresh multiple times and you may land up on web server 2, but then looks like web server 1 is happy handling my request and it is not sending to web server 2 at all. But the objective here is to tell you that the load balancer can be connected to the backend pool. The backend pool here is nothing but the set of virtual machines that are there. You need to configure the health probes and load balancing rules to make sure that the load balancer understands which one of those virtual machine sets are healthy and which ones are not. Load balancer plays a very critical role in balancing the load between various cloud services and virtual machines.